in the last few videos, we talked about the total strain energy. All right. So in the last few videos, we talked about for transverse, axial, and torsional loadings, how we can calculate the total energy due to that applied force, and we know that energy is a scalar value. Okay, so using the loads, displacements, and the elasticity constants in like the areas, we can calculate that total energy. All right. So what we're going to talk about in the next few lectures, and leading into an introduction to finite element methods, is from this energy due to the strain within our stress elements, we can then determine a few things for elastic bodies. We can determine the deflection, the displacement, and the slope for those bodies, and we can also determine the reaction forces and moments for statically indeterminate systems. Okay, so energy methods are the basis of solving statically indeterminate systems. Okay, so there are limitations to energy methods; they're not perfect. So again, you can only assume that there's no energy is dissipated within the system, so we're in the elastic region of our stress strain curve. We assuming that there's only one equilibrium configuration, so that something can only displace in one direction. There's very small displacements, and there's only static loads are concerned. Okay, so static and conservative, which means basically constant loads. All right. So so there are a bunch of different energy methods that have been developed. In this class, we're going to focus specifically on the Castigliano's method and the Rayleigh-Ritz method. Okay, so we're going to use these two theorems to solve a few different types of problems, and then we'll eventually use both of these will be the foundation that we'll use to then introduce finite element analysis. All right. All right. So without any further ado, we're going to get started on introducing Castigliano's second theorem.